Now let's talk about chain and branch organic compounds. I lovingly call these bracelets and charms, and hopefully you'll see why in just a minute. So, do you see how this continuous run here looks like the bracelet, and this little piece here on the end would look like a charm on a bracelet? So, this is hexane. And that's because there's 1, 2, 3, 4, 5, 6 as the longest continuous run of C's. And then we've got this little thing dangling off of it, which is called a branch, which I think kind of looks like a bracelet and a charm. So how do we name these little things that are dangling off? The little pieces that are dangling off are ending in this little YL business. So if you have one little carbon hanging off, it's methyl. 2 would be ethyl, 3 propyl, 4 butyl, etc. So all we're adding is YL to the ending of the typical counting of carbons. So we're still using carbon prefixes because we're still talking about carbons hanging off of the chains. So the charm prefix ends in YL for however many there are. So this is 1, so it would be a methyl charm. Since the bracelet, which is the backbone, has 6 carbons on it, it would be a 3-methyl. We use the same principle with naming this, counting both directions, 1, 2, 3. And if I counted this direction, it'd be 1, 2, 3, 4. Smallest score always wins. So this is a 3-methyl hexane. I like to think of the charm as the surname, the family name. So that's the most important one. It's last, hexane, and this little 3-methyl would be like its first name. To do this, you must always identify which thing is the longest continuous run of carbons, and sometimes it's not that obvious. So you have to count in multiple directions. So if I started here, I could count 1, 2, 3, 4, 5, 6, 7, 8. I could also go over to the right and down. That would be 1, 2, 3, 4, 5, 6, 7. And I could also go up and over to this side. That'd be 1, 2, 3, 4, 5, 6, 7, 8. So in actuality, there are 2 ways that this could be counted. You could say that is the longest run of carbons, and there'd be 8. Or you could say that is the longest run of carbons. Also, there would be 8. Counting either one of these directions makes this charm come off at the same point. 1, 2, 3, 4, if I'm counting the one that's currently highlighted in red, or 1, 2, 3, 4. So either way, when there's more than one continuous run, the location that the charm is coming off will be the same. So this particular one would be a 4, and then of course there are 3, so that is a propyl. So 3 propyl, and because there are 8 carbons on the main branch, 3-propyl octane. What do I do when there's multiple chains coming off, charms coming off of my chain? I still have to count which is the longest continuous run of C's. 1, 2, 3, 4, 5, 6. Well, let me tell you, this definitely wouldn't be it, because then I'd have a charm off of my charm, and that doesn't happen. So I would definitely have to have either going all the way straight across or going straight across and coming down this path. So as you can see, that is the largest continuous run of C's. Then I would simply identify the charms that are hanging off. I have 1 over here, that's called a methyl. 2 is an ethyl. Now we have to say which way is it that we are naming that, methyl or ethyl, and we name that alphabetically, not by the number, but by which letter comes first. So since meth comes after eth, eth would be said first. So this would be, we still have to count golf scores, 1, 2, 3, 4, and 5, 6, 7. This would be 4 and 7 if I counted this direction. 1, 2, 3, 4, 5, 6, 7, that way as well. So I would count lowest letter would win. So it would be 4 ethyl, 7 methyl, and then we have to say its charm name. Its chain name. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 would make me decane. So this would be called a 4 ethyl, 7 methyl decane. Can you see which is the longest continuous run of carbons? If you selected that path, you are correct. Then I have hanging off of this side a methyl, and off of this side an ethyl. Longest continuous run of carbons? Did you make that selection? And as you can see, then I have hanging off of here a methyl and a propyl. That also could have been the longest continuous run. If you go back to our original, I had multiple ways. So one way and yet another way. Both of them have your methyl and propyl. And that propyl charm would be off of carbon number 4, whichever path I took. So identify the number of carbons in the charms and where they are connected. Identify the name of the charms in alphabetical order, and then say the name of the hydrocarbon that makes up the main chain. So you say the chain's name before you say the branches, or I've been calling them charms. They get listed in alphabetical order despite whatever number they are. Once again, they are not said in number order. They are listed in alphabetical order and do include what number they are on. For example, this is a 4-propyl octane because at location number 4, I have a propyl charm. This is a 4-ethyl, 7-methyl decane. Since there's a tie in numbering, the tiebreaker goes to alphabetical. Therefore, this would be carbon number 1 on the far left, because ethyl comes before methyl. This would be a 2,5-dimethyl heptane. We say 2 and 5 are the locations of the reason we say di here is because there's 2 of them. Now, since we're not talking about carbons, we use the Greek prefixes to say there are 2 of the methyl charms. And then its last name is heptane. Hept because in the main chain there are 7 carbons. Ane because they are all single bonded. this would be a 5-ethyl, 2-methyl, 7-propyl decane. Decane, because of the 10 red carbons indicating the longest continuous run, and then you must tell the reader where there are charms coming off, and they are listed in alphabetical order. So the 5 is where the ethyl charm is, the 2 is where the methyl charm is, and 7 is where the propyl charm is. This was determined by counting both directions and getting the lowest score. If I would have started at this one, I get 1, 2, 3, 4, 5, 6, 7. I get 2, 5, and 7. If I count this direction and go from the bottom to the top, my charms are at 4, 6, and 9. That would be higher than 5, 2, and 7. Therefore, we number them in the order which gives them the lowest score, and then we list that in the order alphabetically. I hope this helps with your naming of both chains with branches and determining how to list them once you know their name.